To recap, we've talked about looking at groups rather than individuals, looking at the group averages. We saw that it would make the shape normal. It would ensure that the shape was normal, and it would significantly decrease the spread. And the larger the sample size, the more it will decrease it, the tighter that curve will be. And then last time we saw that the tail probability will get much lower. Right? It's much harder for a group to be off in the tails, off out, 800 or lower than it would be for the individuals. Now, what about the centers? What about being around the mean? So what about 800 to 1100? That's about a standard deviation away on the low end and then a half a standard deviation away on the high end, right? Because the standard deviation was 200. So what's going to happen then? So you can see same curves as before. Purple one is when n is equal to 1. The blue one is n is equal to 30, right? Okay, now just take a look at it. You can see I've got some answers in here, but we're going to find those with Excel. But for the moment, just think about it. If you look at the purple curve, not very little, but only about half of it is shaded in that purple stripe. There's a whole bunch over here in white and a whole bunch over here in white that we're not covering. So that means it's got a fair chance, but not super high. But if you look at the blue curve, here's 1100 over here, here's 800 over here. Almost all of that curve, there's just a tiny bit of white right there, but that's it, right? Everything else is covered. So it's going to be a huge amount, almost the whole thing, in fact. So the whole curve, of course, would be 1. This is actually 0.9969. That's how much it is. So a whole lot. All right. So in other words, it's going to be much easier, i.e. have a much higher probability to be around the mean, close to the mean, when you're looking at groups rather than individuals. So yes, individuals have an average of 1,000, but they're kind of all spread all over the place. That's the purple curve. But group averages, going from room to room and getting the averages, that's going to be really close. Now let's find it. So I guess I will make it its own sheet. So 8.1 notes, page 4, part 2. Okay. So, and as a matter of fact, I'm going to copy and paste a lot of what I did over here because I'm just going to tweak it. Boom. Okay. So I want 800 to be less than x to be less than 1100. Now, if you recall, these are actually the harder things to do with both StatCrunch and Excel. This is more tricky. The between ones are the worst, especially with StatCrunch, actually. Excel is a little bit more sensible, but let's go do it. Okay, so we're going to go to a StatCrunch, open it up, go to Stat, Calculators, Normal, lovely. Okay, so this was 1,000. This was 200. Okay, now how do we do this? We want it to be less than, just bear with me, we're going to do less than 800, which is what we already found, I know. Compute. Okay, so we already did that one. As a matter of fact, I could just copy and paste it right from the other thing, right? It's this guy right here. Okay, so we've got that part. You're thinking, well, Lana, how is that helping us? Well, remember, I want between 800 and 1100. So I'm going to find less than 800 right there. And now I'm going to go do it again, but I'm going to find it less than 1100. Oops, 1100. Compute. There we go. Now that one I'll have to take a snapshot of. So this is 8.1 explanation part 3. Let's try that. Okay, that was saved. So now I'm going to go here. Actually, you know what? I'm going to open this in another tab if it'll let me. Nope, it's not going to let me. Fine. I will do StatCrunch there. That way I can have my results in one window and then my calculations in another, just to make my life simpler. Okay, copy. Go back here and paste. Okay. Now, what am I doing? Well, I want to take this high one, which was 0.69146, blah, 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 and I want to subtract. So it's equal to 0.69146246 minus 0.158 65526. Follow that? I'm taking the high one, this one to 1100, I'm subtracting away this part. So if you can imagine this graph on the right, if you vacuumed off all that 800 part, you'd have only the in-between stuff, which is all we were really interested in. Okay. Now what about if it's 30? Well, remember that means the standard deviation shrinks to 36.5. Okay, so I'm going to have to do this again, but for change the standard deviation right here to 36.5. Compute. Look at that. Right? Huge. All right, so snapshot. 8.1 explanation part 4. Export. Okay. Yeah, that's what I gotta do. Oops, go here. Going to copy. There we go. Go over here and I'm going to paste it in. Okay, so this is when it's for 30. Make it a little bit smaller. So I know what you're thinking. You're thinking, well, how does that? Oops, that didn't work at all. Hold on, I got the same one. Did I not do it? Oh, you know what? My results. Hold on. I forgot. It was part 4. I must have to click refresh. Sorry. Copy. Going back. Paste. There we go. It's the same deal. It's just that so much more of it is covered, right? There's only a tiny bit over on the right. See it right there? Only that little bit that is not covered. All right, but we already have the other part already copied. It's right here. So I'm going to copy and paste that into here. There we go. Okay, so for the second one, I need 0.9969255. So I'm going to do this over here. So equals 0.99, what was it? 69255 minus 0.123456721332252. Boom. There we go. Which, of course, this is so tiny that it essentially doesn't matter. But, you know, there you go. It changed the decimal places out here at about the 7th decimal place. Okay. All right, so let's do it again with Excel. Excel is actually a little bit quicker for this, to be honest, than StatCrunch. So all you have to do with Excel, oops, there we go. Cool. So you can type it all in at once. Norm.dist, we want the one on the right, that high one, that 1100. So you say, okay, 1100, comma the mean, which was 1000, which I could just type it in, comma 1000, comma the standard deviation was 200 when we're working with individuals. True, close that parentheses. So that's this one, the one on the right. And if you wanted, you could find each part separately. Like I could find this was x is less than 1100 right here. And then I could do it again for a less than 800 and subtract, right? Here, I'll do that just for the fun of it. Okay, so then I could do x is less than 800, which technically I already had in place and I just lost it, but that's okay. I'll just go in here and change that number to 800. Oops, I made it something else. 8700, no. There we go. And then so the probability I was actually looking for is equal to this number minus this number. Oopsie. That. Boom. That's what we wanted. Notice, by the way, that it's the same answer that I got from StatCrunch right here. Highlight. Okay. And then this one right here, hopefully will be the same that I get down there. As a matter of fact, that's a good idea to do this anyway. I will highlight these so that they're similar so you can see the comparison. So that one's with Excel, or StatCrunch, this one's with Excel. But you can see they're the same answers. All right, let me go back here. All right, so you could do it like that, like we just did. You can say, okay, you know, find each one separately and then subtract, or you could just do it all at once. I could say, okay, equals norm.dist for 1100, comma 1000, comma 200, comma true, close parentheses, minus norm.dist, and then it would be 800, comma 1000, comma 200, comma true. And there, same thing. right? And it finds it all at once. So whichever way you like to go. If you want to find each part separately and then subtract, that's fine. If you know enough to go, oh, I just need to subtract, that's fine. Whatever. All right, now what about n is equal to 30? Okay, so it's the same deal, right? It's the same problems. It's just that everything's going to change a little bit. So instead of 200, I want to use this value, 36.5. And I'm going to give it dollar signs. That way it never changes. And then I'm going to drag it down here. Make this 800 right here. There we go. So again, 800, 1,000, that 36.5 is my standard deviation, standard error, true. And then I'm going to subtract the two of them, right? Or you could just do it all at once, right? I'm going to copy and paste that. Okay, so I would say 1,100, instead of 200, I'm going to say that value 36.5, which was cell B9 for me. And same thing right here, delete that, make it 36.5, enter. There you go. Same answers we found above. So if you want to do it all at once, that's fine. If you want to separate it, whatever, it's all good. But now we know how to find it with both StatCrunch and with Excel. And again, you don't have to do this intermediate stuff, but I think it's helpful, especially for finding the standard error, to kind of have it in a cell that I can just refer to. Okay, so I just proved to you that these numbers are true. And I didn't just make them up, right? So for when it's n equals 1, it's only 0.5328. But when it's for n equals 30, it's 0.9969, right? It is much higher for the group than for the individual, because groups are much more likely to be right around that center. It is very hard for them to be off in the tails and very easy for them to be near the center. Okay, let's stop right there, and we will pick back up for the next example, which is the GRE example. So I'll see you back here then.